This is homework 8, question 2. So question 2 asks about let n be a Poisson process with parameter lambda, that is p of n, which is the number of random points arriving the time t1 and t2 is equal to k, which is equal to e to the power of minus lambda in bracket t2 minus t1 times lambda bracket t2 minus t1 to the power of k divided by k factorial. So now define a new stochastic process as x of t is equal to 1 if n is odd, and x of t is equal to minus 1 if n is even. So this is a graph as showed, like signal. And subproblem A asks about find the probability of x of t is equal to 1. So x of t equal to 1 is equal to, because x of t equal to 1 when n is odd, so we can write that the probability of k is equal to is odd in 0 to t times. So based on the Poisson process, we can write the sum of k is equal to odd, e to the power of minus lambda minus 2 minus t2 minus t1 times lambda t2 minus t1 to the power of k divided by k factorial. So t2 minus t1 in this situation is just t, so it is equal to sum of k is equal to odd e to the power of minus lambda t times lambda t to the power of k divided by k factorial. So it can be right, so we open up the sum, it can be right that because odd it is 1, 3, 5 blah blah blah, so it is equal to e to the power of minus lambda t times in the bracket lambda t plus lambda t to the power of 3 divided by 3 factorial plus lambda times t to the power of 5 divided by 5 factorial plus to be continued. So for the equation in the bracket, so we can write that it can be write that it is equal to 1 plus lambda t plus lambda t to the power of 2 divided by 2 factorial plus lambda t to the power of 3 divided by 3 factorial plus blah blah blah. This is equivalent to e to the power of lambda t, so minus 1 minus lambda t, this equation which is equivalent to e to the minus lambda t. So we can get that it becomes two of these terms in the bracket. So we can write this part as e to the power of lambda t minus e to the power of minus lambda t divided by 2, which is this bracket, and if we want this part, we just times e to the power of lambda t. So e to the power of minus lambda t, so it becomes 1 minus e to the power of minus 2 lambda t divided by 2. So the probability of x of t is equal to 1 is equal to 1 minus e to the power of 2 minus lambda t divided by 2. And question B asks about find e of x of t. So the mean of x of t we can write, because x of t is either 1 or minus 1. So for the probability that it can be open to 1 times the probability of x of t is equal to 1 plus minus 1 times p of x of t is equal to minus 1. So we want to know the p of x of t is equal to minus 1. So do the similar process as the subproblem A. So we can get that the probability of x of t is equal to -1 is equal to 1 plus e to the power of -2 lambda t divided by 2. So the mean of x of t is equal to 1 minus t to the power of -2 lambda t divided by 2 minus 1 plus e to the power of -2 lambda t divided by 2. So it is equal to minus e to the power of -2 lambda t. And C asks about find R of T1 and T2. So R of T1, T2 is equal to E of x of T1 times x of T2. So it is similarly as 1 times the probability of x of T1, x of T2 is equal to 1 plus -1, the probability of x of T1, x of T2 is equal to -1. So it becomes the probability of x of T1, x of T2 is equal to 1 minus the probability of x of T1, x of T2 is equal to -1. So it becomes e of -2 lambda T2 minus T1 when T2 is larger than T1, or e of -t lambda T1 minus T2 when T1 is larger than T2. So the R of T1, T2 is equal to e to the power of -2 lambda absolute value T2 minus T1. Because we know that this e of x of t is similarly as e of x of t times T1 times x of T2. So these parts can be open to T2 minus T1. And for D, ask about e of x of t. Is x of t WSS? So due to e of x of t is equal to minus e to the power of -2 lambda t, which is not WSS because this value varies with the t